Welcome to the Endogenous Dynamic, Structural Geology and Tectonic 1 course. I'm teaching this course in English for the purpose of the podcast. The same lecture is going to be held in German 1.5 hours later. Because this year we have a very large number of students, we have decided from last year, the exams will not be open book, so you will not be allowed to bring all the material that you have to your use, and the exams will be, at least for a large part, multiple choice. Now, during the tutorials, we are going to give you examples of how these multiple choice questions are going to be framed. So you will get some good exercise. We are also going to try to adapt the content of the tutorials in such a way that it will be more useful for understanding the content. Okay, in this first lecture, I'm going to talk to you a little bit about the administrative parts. I think I've done that now. I'm going to tell you a little bit about what it is, structural geology and tectonics. Then I'm going to define a couple of very important words or terms that we are going to use. Then I will tell you something about the kinds of models that we have in structural geology and tectonics. And then we are going to start with some of the hardcore mathematics, and I will tell you a little bit about vectors, orientation analysis, and there will be something about stereograms or stereo nets. So, a little bit more about administration. This, please, you forget. This is a leftover from last year because I didn't get Sonja's version of the PowerPoint. We have a website for this course, and you can sign up for that, and you can download material. There are exercises. The lecture PowerPoints are there. There are links. But you have to sign up for it. You have to get your own password. There are, of course, a lot of textbooks, online courses, and lecture notes. There are a huge amount of journals. So, in general, structural geology and tectonics is a subject for which you will never need more books. Especially tectonics, there are books at every level, from the school to the advanced. Most of these books tell you more or less the same thing. Okay, this is one of the reasons why I did not write a script. I did not write down the text of this lecture, because everything I say, or very much everything, is available in books in different kinds. This is just the contents of the lectures. I'm going to talk about the basics, which is vectors, which is stress, which is a little bit of mechanics, and then I will tell you all the different kinds of structures that you can find. I'm going to tell you about fractures. I'm going to tell you about faults, how rocks are deformed, about shear zones. Then I'm going to tell you about all the different kinds of plate boundaries at a much larger scale. I'm going to talk about rifts, about strike-slip faults, about subduction zones, mountain building, and in the end, maybe a little bit about salt tectonics. So this will be a one-semester course. Structural geology and tectonics. The name comes from Latin and Greek. Struere is to build, and tectos is a builder. Structural geology is about deformations, displacements, movements, structures in the earth. And tectonics is more or less the same, but a much larger scale. So the real difference between structural geology and tectonics is the scale. A few kilometers down to micrometers is typically a structural geology theme. Up to thousands of kilometers is, of course, the tectonics. But there is not a real sharp boundary, and that's why this course is basically taught by one professor. Structural geology and tectonics are quite an exciting topic. I like it very much. Of course, that's why I like my job. One of the things that is very motivating is that the subject is interdisciplinary. We work together with many other fields, with material science, Materialwissenschaften, with people from mechanics, computing, geodesy nowadays is very important, geophysics, geochemistry, petrology are all fields that have their contributions to our kind of work. Why is structural geology and tectonics so complicated? Or why do you really have to spend a whole semester and later in your studies many more lectures on this? Because of the range in scales. Structural geology covers an enormous range in time. Just think about an earthquake, which happens in a second, and the movement of a plate, which happens in many millions of years. And everything in between has its role. And it is conceptually really quite difficult to understand how many little earthquakes can contribute to the movement of plates. It takes time to let these concepts sink in. And the range of length is also enormous. This is a factor of 10 to the 10th. Some people in structural geology are interested in how crystals deform in thin sections. Okay? And what can we tell from a deformed crystal of quartz? And others are considering whole continents which are moving over our planet. Enormous differences in length scale. And again, these structures are coupled. They have something to do with each other. It is very difficult to just treat one of these length scales. You have to consider them all. The rocks that we are looking at are heterogeneous. They are discontinuous, and I'm going to tell you what all these terms actually mean. What is happening in the Earth at the moment is not accessible. The deepest borehole that we have ever drilled is 10 kilometers, and so much that we are interested in is happening much deeper. We cannot take samples from the Himalayas, which is deforming right now. We cannot even do experiments which last 1 million years. That's of course quite difficult. So in comparison with, for example, engineers who make car parts, our life is much, much more complicated. We don't have a well-defined metal, we don't have a well-defined factory, and it is very complicated to come to a good and very exact understanding of what is happening in the Earth. Of course, we can do a lot of post-mortem observations. So after the rocks have died, they don't really die, but they come to the surface, and then we can sample these rocks and we can study them. And in this respect, structural geology is a little bit comparable to what people do in forensic laboratories. You see a dead body and you try to figure out who killed it and what were the conditions of the death. Okay. Let's now look at a few of these terms. The first one is homogeneous and heterogeneous. Homogeneous is something that has a certain property that can be color, or it can be density, or thermal conductivity, or crystal structure, which is the same everywhere in a part of the space. That is homogeneous. Heterogeneous is when some property is not the same over this space. And why I wanted to show you this huge rock here is granite, and for the purposes of looking at it from the distance, it is really quite homogeneous. You can see that from the fact that the fractures that go through it really are quite straight. It's homogeneous. But if you look at the granite from closer, something like this here, then you see that the granite is heterogeneous. So homogeneous is the property which is continuous over space. But what you have to keep in mind is that homogeneity is always a question of scale. Everything homogeneous, heterogeneous can change if you look closer or if you take a little bit more distance and you look from further. To say homogeneous is only useful if you can say over what scale it is homogeneous. Continuous and discontinuous. Continuous is something where a property doesn't change sharply. Okay, so it can change, but it doesn't change in a jump. For example, I took this picture of a granite which contains these fractures. A fracture is really a discontinuity. Okay, so a rock which is fractured is not continuous. But again, this is a question of scale, because if I have a granite which has a lot of fractures and I look from a distance, it can look rather continuous. Isotropic, that's another important word that will come back in the lectures. Isotropic is something that is the same over different directions. So an isotropic thermal conductivity means that in every direction the heat will travel at the same velocity. Okay. Now, the bread and butter of structural geology is deformation. Rocks deform. And rocks deform in many, many different ways. Deformation is certainly not something that only rocks do. Deformation is something that happens all around us in many different ways. And that's why I made this slide for you. Here is a deformed house. And this house has deformed very slowly. In earthquakes, houses deform in very different ways. And now you can ask yourself the question, is this deformation homogeneous? Well, I would say no, it's not homogeneous, because the deformation here is clearly very different from there. One thing that will come back many times in these lectures is that the reason that you can say that this deformation is heterogeneous is because you know how the house looked like before it was deformed. Many times we are looking at deformed rocks and we make some kind of an idea of how it was before. It was maybe layered, or it was a granite, or something else. So the lower part of the house is deformed, the upper part hasn't. Is the deformation continuous or discontinuous? Well, I would say that it's discontinuous, because the deformation here is rather homogeneous and continuous. It doesn't change sharply, but here there is a sharp change. There is a discontinuous change. Okay. Here is a folded rock, heterogeneously deformed, of course. And you can have some kind of an idea that maybe these bands here were more or less flat at one time in the past. This is a fold, heterogeneous, discontinuous deformation, completely different from this one here. And here is a pile of newspapers that I actually deformed twice. Okay, the pile of newspapers had the yellow and blue stripes, vertical, and then I sheared the pile of newspapers and then I bent it. So this pile of newspapers now was deformed twice. And very similar structures you can see in the Alps or in the Ardennes mountains, and then you can analyze this and tell that the rock was deformed in several episodes. Okay. To understand these kind of deformations, it is important to get some basic understanding of mechanics. The deformation is typically something that happens or is analyzed or is understood within the field of mechanics. And mechanics is all about